Hi everyone, and welcome to OMMC Problem of the Month for December. So this is our problem. Let triangle ABC be such that the midpoint of BC is D. E is on the opposite side of AC as B on the circumcircle of ABC such that angle DEA equals angle DEC and omega is the circumcircle of CED. If omega intersects AC at X and the tangent to omega at D intersects AB at Y, show that XY is parallel to BC. Okay, let's draw a diagram. So have a triangle ABC. The midpoint of BC is D. And then we somehow have a point E on the circumcircle of ABC that is on the opposite side of B as on the opposite side of AC as B, such that somehow DE bisects angle AEC. Okay, so let's see how we could possibly figure out where E is. Well, if we have E over here, and then we draw a line DE, we somehow need angle DEA equals angle DEC. And if we look at what arcs these angles inscribe on the circle, if we let the point at which DE intersects the circumcircle again be P, then we get that arc AP and arc CP of the circle must be equal. So AP equals CP if P equals DE cap the circumcircle of ABC. And actually, we can now identify P because P is just the arc midpoint of arc ABC. Therefore, P equals arc midpoint of that arc ABC. Okay, so that's pretty useful. We now know where E is. Okay, let's move on to the rest of the problem. We need to draw the circumcircle of triangle CED. So that's going to look like this. And that circle will intersect AC at X. So this point is X. And the tangent to the circle at D intersects AB at Y. But let's just hold off on drawing that for now and just think about X. So, okay, there are many ways to do this problem, but I'm going to present the solution that uses spiral similarity because it's very cool. So basically what spiral similarity says is if you have two circles that intersect at 2 points, and then at one of these points, we draw two rays that both intersect the circle at two other points. So we have these two purple points here and these two pink points here. Then the triangle formed by the second intersection point and the purple point is similar to the triangle formed by the second intersection point and the pink points. So basically, I'm going to draw it more clear. So basically the purple triangle is similar to the pink triangle. Okay, so that's the main spiral similarity level. So let's see how we can use that here. Well, we have two circles, the yellow circle and the white circle, and we have two rays coming from point E intersecting the yellow circle at X and D and the white circle at A and P. So spiral similarity tells us that since C is the second intersection point of these two circles, we have triangle CXD similar to triangle CAP. All right, cool. And actually, this is very nice because triangle CAP is very cool. It's isosceles because P is the arc midpoint. So from triangle CAP, we know that AP equals CP. And then if triangle CXD is similar to it, then we must have that XD equals CD. All right. Okay, so let's see what that would look like in the diagram. It would basically look like this blue segment is equal to that blue segment. And actually, we know that D is the midpoint of side BC, which means that BD is also the blue segment. So we have 3 congruent segments. Therefore, BD equals XD equals CD. Okay, nice. So now what does the rest of the problem say? We need to show that XY is parallel to BC. So, okay, let's draw the tangent to the yellow circle at D now, because we kind of have the rest of the problem under control. So it's going to hit AB at Y, and then we somehow want to show that XY is parallel to BC. Okay, so let's just take a step back and think about what we have in the diagram so far. So we have like a blue segment on the bottom that has a midpoint, and we have like another blue segment there, and all 3 of the blue segments are equal. So we have B, D, C, and X. And then, oh yeah, and okay, something else important to note maybe is that YD is going to be parallel to XC, because let's think about it. If we have an isosceles triangle in a circle, and it looks like this, and then we have the tangent to the like intersection of the 2 blue sides, then that tangent is going to be parallel to the white line, because this triangle is isosceles. And I guess you could even angle chase it. Like you could show that this angle is equal to this angle is equal to that angle is equal to that angle. But anyway, these 2 white lines are going to be parallel. So we have that YD is parallel to XC. So, okay, going back to this little diagram here, we have like this line that Y lies on, and we want to show that XY is parallel to BC, which would basically just be the same as showing that Y is like the point that forms a parallelogram with X, D, and C. So we kind of want to show that YXCD is a parallelogram. YXCD is parallelogram. Okay, so yeah, let's see how we can do this. Well, it might be useful to note that Y is on AB. Like that was the definition of Y. So maybe let's do a little more angle chasing. So let's make some more space. Actually, I'm just going to draw another diagram up here. So, all right, we have the circumcircle, and I don't think I'm going to draw as many points as before on this one. But yeah, okay. So we're still going to have P, because P is pretty useful as it's the arc midpoint. And then, okay, we had E up here. Let's see. So, yeah, actually, no, I am going to draw the whole diagram. So E, D, and then the yellow circle. Okay, and then we had that, okay, so AE intersects at X. Okay. So, and we knew that XD equals DC equals BD. So, all right, and then we also had that like XC was parallel to YD. So Y is going to be up here. Okay, now actually the rest of this problem is just angle chasing. But we also might want to use this piece of information. So, all right, do you agree that it would suffice to show that angle B is equal to angle XDC? Because if we knew that angle YBD was equal to angle XDC, since YD is parallel to XC, then we would have that triangle YBD is congruent to triangle XDC. So if angle YBD equals angle XDC, then triangle YBD would be congruent to triangle XDC. Basically because you could angle chase it to show that like they're similar, and then since BD equals DC, they must be congruent. So, all right, and then if we could show this, we would be done, because then both of these triangles would be congruent to triangle DXY. So, okay, we just want to show this basically. We just want to show that these two pink angles are equal. And actually, this is not very hard because we can just use cyclic quadrilaterals. So angle YBD equals angle ABC, which is angle APC. And then because triangle CXD is similar to triangle CAP, this is also equal to angle XDC. So yay, we just did it. Angle YBD equals angle XDC. And so then this whole thing must be true. Sorry, I'm kind of going out of order here, but yeah. And then we know that triangle YBD is congruent to triangle XDC, which means that obviously YBDX is a parallelogram. So, and parallelograms have parallel pairs of opposite sides. So YX is parallel to BD as desired, or BC. So we're done. Okay. Thank you for watching, everyone, and make sure to join the OMMC server if you have not already. And yeah, stay tuned for more. Thank you.